Good afternoon, students. I am Rekha Nair and my colleague Archana Nair would be talking to you about numerical integration today. Both of us belong to Sri Jairam Bhai Patel Institute of Business Management and Computer Applications, popularly called NICM. Today, let us talk about numerical integration. Have a look at the slide. What is integration? When we talk about integration, it is understood to be the area that is covered under a curve. In order to find out the area under the curve, which is unknown, we actually approximate a polynomial px. This polynomial is a known polynomial that is approximated by the user. In order to find out the area under the curve, let us consider an example. Please take a look at the screen. We have a curve f of x. This is approximated by a polynomial called px. The basic idea is to find the area under the curve, which is called the integral of the curve fx. The area under the curve is bound by the points x equal to a and x equal to b. Since we are trying to find out the shaded area that is bound between the points x equal to a and x equal to b, we call this a definite integral. So, numerical integration is basically finding out the definite integral covered under the curve f of x by approximating a function px. Today we would be covering three integration formulae. First, trapezoidal rule. This rule is also called a two-point integration formula. This is called two-point because 2 points on the curve are considered to find the area. Second, Simpsons 1/3 rule. This integration formula is called a three-point integration formula. And the third, Simpsons 3/8 rule, which is called a 4-point integration formula. All these integration formulae uses the Newton's interpolation polynomial to approximate p of x. Let us now look at the screen. The first method, trapezoidal rule. Let us consider the curve f of x. And the basic idea is to find out the area covered between the points x equal to a and x equal to b. In order to do so, the trapezoidal rule divides the entire area under the curve into n strips, each of width h. Since we are using Newton's interpolation polynomial, it is necessary that the strips be of equal width because Newton's interpolation polynomial is used for equispaced or equidistant points. Have a look at the screen. Under trapezoidal rule, we consider 2 points xk and xk plus 1. In order to find out the area covered under the curve, the entire area is divided into equal strips, and now in trapezoidal rule, we shall consider to find the area of the kth strip bounded between the points x equal to xk and x equal to xk plus 1 with a strip size h. In order to find the area, we use the integral, definite integral, which is given by ik integration xk to xk plus 1 y dx, where y is our fx, the function. On simplifying this, we get the area covered by the kth strip, which is denoted by ik and given by the formula h by 2 yk plus yk plus 1. That is, this denotes the area that is covered by the kth strip. Going back to the diagram, here we said that in trapezoidal rule, the entire area is divided into multiple trapezoids. we have found the area of kth such trapezoid. Now, in order to find the area covered under the entire curve, we will sum up the areas of n such kth strips and we would get the value of the integral, and that would be got by I, which is given by summation k running from 1 to n ik. That is, we would now be summing up the individual areas I1, I2, I3, In. There are the areas of the n trapezoids that were formed. And finally, we get the area or the integral I, which is given by h, which is the strip size, divided by 2, multiplied by y1 plus y2 plus 2y3 plus 2yn plus yn plus 1. Now let us take up an example so that you can understand how to use this formulation. Take a look at the teleboard.
Suppose we want to solve integration from 2 to 5 x square plus 2x dx. Suppose our aim is to solve this integration by dividing this interval into n sub-intervals. I'll take the value n is equal to 6. Suppose I want to divide this interval into 6 sub-intervals and then find out the value of the integral. So first what we have to do is, what should be the step size which we are using for that. So for calculating step size, h is calculated as b minus a divided by n. Actually the integration is, this is the value of a, this is b. So it turns out to be 5 minus 2 divided by 6, that is actually 3 by 6, that is 0.5. So the step size which I have to use for this is 0.5. So now our next aim will be to tabulate the x values and the corresponding f of x values. That is, y takes the value f of x. If I take x values, it starts from 2. So keep on adding the interval step size. So if it is 2, the next will be 2.5. The next value will become 3. The next will be corresponding 3.5. The next will be corresponding 4, 4.5, and the last value up to 5. The last value of the integral is actually 5. Now, putting these values of x into the function which is given to us. What is the function which is given to us? It is this one, x square plus 2x. So we have to put each of these x values into that function fx. So what we get? In this function, that is x square plus 2x, if we put x equal to 2, the answer we get is 8. Now, in the same function, if we are putting the value of x to be 2.5, we get the value 11.25. Again, the remaining values, if I put 3, I'll be getting the answer 15. If I put 3.5, I'll be getting 19.25. If I put 4, I'll be getting the answer 24. If I put 4.5, I'll be getting 29.25. And if I put the last value 5, I'll be getting the answer 35. So these values of fx are obtained when we put the values of x into that formula, that is of f of x, x square plus 2x. We are putting values of x in this formula. Clear? Okay. Now, when I have found out this y is equal to f of x, the first value which I have got, this is my y1. The second value which I have got is y2, this is y3, this is y4, this is y5, y6 and y7. So there are 7 points which I have got. Now, we already know the formula of trapezoidal rule. Have a look on the slide.
The slide.
So you can see the formula of trapezoidal rule. It is I is equal to h upon 2 y1 plus 2y2 plus 2y3 and so on plus yn plus 1. So what we do is, we are having y1, y2 up to y7. We put these values inside the formula and even take h is equal to 0.5. If we substitute all these values in that formula, we will get the answer I is equal to 60.125. This is the answer which you will be getting when we put all these values into that formula. Now have a look on the slide.
Now we shall talk about Simpsons one-third rule. Simpsons one-third rule is a step further, and we said it is called a three-point integration formula. In case of Simpsons one-third rule, the entire curve area that is bound between the points x equal to a and x equal to b are again divided into equal strips or strips of equal width h. Further to the trapezoidal rule, where we considered only 2 points, now we will be considering 3 points, and that is why Simpsons one-third rule is called the three-point integration formula. In case we consider the 3 points, x equal to xk, x equal to xk plus 1 and x equal to xk plus 2. These 3 points would now be covered by a second degree polynomial, which is also called a parabola. Now we find out the area that is covered by 2 strips. In trapezoidal rule, we found the area covered under 1 strip. Now to improve the approximation, we take 2 strips at the same time, and we find the area that is covered by the 2 strips bound between the points xk, xk plus 1 and xk plus 2. In order to find the area of the kth strip and the k plus 1 strip, we use the integral ik, which is given by integration xk to xk plus 2 y dx. Again, y represents our fx. On simplification, we get the area of the curve ik equal to h upon 3 multiplied by yk plus 4yk plus 1 plus yk plus 2. This is the area that is covered by 2 consecutive strips, kth strip and the k plus 1 strip. In order to get the total area that is covered under the curve f of x, we would now sum up the individual areas. In this case, we have taken the area of 2 strips together. The entire area under the curve is divided into n different strips. So when we sum up the area, we need to sum up only n by 2 strips, because when we take up the first strip, the kth strip, we are considering the area covered by the kth strip and the k plus 1 strip. So when we are summing up the second area, it is the k plus 2th strip and the k plus 3rd strip, and so on and so forth. And hence, the summation is now done from k equal to 1 to n by 2, I to k minus 1. N by 2 because now we are halving the total number of intervals, since we are considering 2 strips at the same time. On simplification, we have I equal to h by 3 multiplied by y1 plus 4y2 plus 2y3, so on and so forth, plus 4yn minus 1 plus yn for the n intervals. This is the Simpsons 1 by 3 rule. On performing an example, we will find out that the Simpsons 1 by 3rd rule gives us a better approximation of the curve, because it considers 3 points at the same time, and it is approximated by a second degree polynomial, and hence the approximation of the area under the curve fx is much better and is a better result. Let us take up an example. Please look at the teleboard.
Okay, to solve an example of Simpsons 1 by 3 rule, let us take this integral. Suppose we want to integrate minus 1 to 1 e raised to x dx. Means we want to integrate the function f of x, which is e raised to x. So we have to integrate between the values -1 to 1. Now I am dividing this into n is equal to 8 subintervals. We are dividing it into n is equal to 8 subintervals. Now if I want to divide it into 8 subintervals, let us take what is the step size h. As we have done earlier, it is b minus a divided by n. So b minus a divided by n, that is 1 minus 1 divided by 8, that is 2 divided by 8. The answer is 0.25. So the value of h which you have to take, that is the step size, is 0.25. Now the interval of x, our aim is to tabulate the values now for x and what is y is equal to f of x. Now first of all, the range of x. This starts from -1. The first point which we are going to take is the lower limit, that is -1. Keep on adding 0.25 to that value. So -1 plus 0.25, you will be getting minus 0.75. Again add 0.25. So you will be getting minus 0.5. Again add 0.25 minus 0.25. Doing that, you will be getting 0, 0.25, 0.5, 0.75 and 1. So the upper limit is 1, so we will be going up to 1. Now if we put each of these x values, inside the function e raised to x, in the function e raised to x, we are putting different values of x which we have just found out. So putting those values, we will get the value of y is equal to f of x. So when y is equal to, if I put x equal to -1 in e raised to x, we get the answer to be 0.37. If I put x equal to -0.75 in the function